Welcome to our very first keynote. Today I'm very excited to talk about how DEP is going to accelerate the adoption of renewable energy DC microgrids. Now, we won't solve everything today, but we're going to share with you where we think the problems are, and we're going to share with you what we're going to do about it today. My co-founder and I, we've been thinking about this for the last 3 years. We always had the feeling that DC microgrids are the most efficient way to build any renewable energy microgrid. Industry experts agree that this is the way to go if you are considering to build a renewable energy microgrid. And engineers also agree that this is the way to build microgrids. However, we don't see their adoption rate exploding. Why is that? We also asked ourselves another question. Why is it that you can't buy a DC microgrid on Amazon? And this kind of led us down a big rabbit hole. So we identified 6 problems. And today I'm going to walk you through those 6 problems. So let's start with problem number 1. The design lifecycle of AC or DC microgrids is complex. Let me show you what I mean. Typically, you start at your project goals. You start thinking about, why do I need a microgrid and what am I going to do with it? What benefits is it going to yield to me? Whether that's technical or economic benefits. Is it going to provide resiliency? Is it going to save me money? What is it going to do for me? And where am I going to put this microgrid? These first 3 steps we consider as the concept phase of the microgrid. And it's very time consuming and cumbersome because the information is fragmented out there. And it takes several weeks to months to even answer these. If you get through the concept phase of a microgrid, the next step in a design lifecycle is to do the design and engineering. Now, this is a very complex task because it involves several engineering disciplines. Anything from controls engineering to simulations engineering to electrical engineering to mechanical engineering. It involves working with developers and architects. It's a very complex process because there isn't a single person that has all of the information, and all the information has to be coordinated. If you do get past the design and engineering phase, you typically get into the procurement phase. Now, the procurement phase can either make you go forward or propel you back into the design phase. It depends if the supply chain can support your design. But there's a bigger problem with the procurement phase. Unlike in the consumer world, the prices are not publicly available. There isn't an Amazon catalog where you can just search for microgrid equipment. We know the equipment is out there, but it's very hard to find, right? So you have to go out to various manufacturers, you have to find the representatives on LinkedIn, you have to email. And if they let you in, and I say if, then you might find out if the equipment is available and how much is it going to cost you. After the procurement phase comes the implementation phase. I'd say this is the simplest phase of a microgrid design, meaning installers are very used to installing equipment out there. You just have to give them the appropriate information. After the implementation phase comes the commissioning phase. If you're building a multi-vendor microgrid, you typically have to involve various vendors and their application engineers during the commissioning process. You bring up your power conversion units typically separately, your solar panels, your batteries, your EV chargers. You make sure every equipment works according to the specifications individually before you run the system as a whole and you test the system performance. After the commissioning phase comes the operation and maintenance phase. This is when you hand off the system that you've tested to the project owner, developer, or a professional O&M company. And if you're really lucky, you might even get to upgrade, expand, or retrofit your microgrid. Now, this is a big problem, and we're not going to solve all the problems today. The big problem here is that the soft costs going from the concept phase to the deployment, operation, maintenance phase are astronomical. It takes several years to deploy a very simple microgrid, especially if you make it multi-vendor. What do we mean by multi-vendor? By that, what we mean is that we know that there are companies out there that make converters, there are companies out there that make circuit breakers, there are companies out there that make batteries, but how do you combine them together to make a cohesive microgrid? But we'll talk about it a little bit later. This is what we thought the design lifecycle of a microgrid was, but actually the design lifecycle starts at phase 0, and we call it the ideation phase. This is where the true magic happens. This is where you start thinking about a microgrid. This is where you do back of the napkin calculations. This is where you sketch stuff out on a paper. You open a PowerPoint presentation. This is where you start sharing an idea with key stakeholders, with your colleagues. This is where the majority of the work gets done. This is when you're like, yeah, we think we were going to embark on this journey of getting a microgrid. So what's problem number 2? So problem number 1 was the design lifecycle is complex, and the soft cost associated getting from a concept to implementation are astronomical. So problem number 2 is the lack of ideation tools. Let's look at how concept designs are done today. When somebody has a thought or an idea of what they want for a microgrid, they typically grab a piece of paper or they go straight to PowerPoint. And when you go to PowerPoint, you build some blocks, you label them what they are, you add some dash lines for zoning, you add some lines, label them as voltages, you add some loads and say, aha, this is my microgrid. And it feels simple, and it should feel that simple. But then if you when you spark that imagination in somebody else's head, another variant can come on. Another variant can come on with actual equipment out there. Pictures and more labels and more definitions. You may want to show the direction of the power flow. It's all relevant information. But now it's represented differently, and it's somewhere else again. You might want to simplify things, color code the different voltages that exist in a microgrid. After all, a microgrid has various voltages, anything from 480 volts AC to 120 volts AC, from 350 volt DC to 1000 volts DC to 24 volts DC. You gotta be able to very succinctly represent this information to the key stakeholders. So you draw another concept, and there's all these variants out there that take a lot of time to put together. But all this information is extremely valuable. And there's hundreds and thousands of examples out there on the internet how people are trying to get their ideas across today without the proper tools. Here's an animation of an example of how people are trying to standardize the design process to make the iteration much faster. This is done in Inkscape, and the video is sped up by 8x. In this particular case, The individual drawing the microgrid has made some symbols and is trying to align them ever so nicely just to make the connections happen so they can show this schematic to the engineer, show it to the key stakeholders, because it does add a lot of value. But remember, we're just ideating here. We're not actually engineering a system. So what's the problem with this? The problem is that the drawing process is cumbersome. Symbols are not standardized, there's no standard color coding, and it's not possible to attach attributes, so you don't know if you're designing with a real component. You might find out after you do your drawing, the component doesn't exist, and now you have to change your design all over again. And then what? So problem number 3. The products are homeless. They don't have a home. We believe that the product to build a DC microgrid exists out there. The problem is they're all over the place, and there is not a single place for them to consider a home. What are some of the key microgrid products? Let's categorize them. Let's categorize them as converters. This is the heart of any kind of microgrid because it moves the electrons around to your will. And they come in different flavors. They come in something called a power conversion system, a maximum power point tracker, a charge controller, a rectifier, an inverter, a DC-DC converter. At the end of the day, these components are just a converter. Their name indicates a different function. And there's thousands of them out there. Another key component of microgrid are solar panels. Solar panels come in various flavors, sizes, shapes, but they all do the same thing. They take solar energy and they generate electrons. Batteries. Batteries are part of a DC microgrid. They allow you to store energy. They come in various shapes, sizes, and forms, but at the end of the day, they just store energy for use at a later time. What other pieces exist in a DC microgrid? Protection devices. Protection devices come in various flavors as well. You have your molded gate circuit breakers, your solid state circuit breakers, your branch circuit breakers, or your fuses. There's various manufacturers that make these pieces of equipment, and it's very hard to make sense on which product you should be using in your actual microgrid design. Then another large category are EV chargers. The only way to DC fast charge today is to do it with DC. And so we have anything from a level 1 to level 2 and a level 3 EV charger. They have various inputs and outputs and communication protocols. But at the end of the day, they're just that, an EV charger. And somehow we have to make sense about which is available for my concept and for my design. So what do you do today? Today you go on Google. So we did that. You go on Google and you say, hey Google, give me a 700 volt, 30 kilowatt DC-DC converter. And this is what Google said. Google suggested that we should look at a 30 kVA, 3-phase AC transformer, or some component for a Honda Civic, or a 10 kilowatt DC-DC converter, or maybe a 3 kilowatt mean-well converter. This is not very helpful. So Google is not useful to find the parts that you need. So you go into key online distribution places like Mouser, Newark, DigiKey, or Newark. And it's okay to browse these websites, but they're not specifically built for microgrids. And I oftentimes hear that these are specification tools. And today I'd like to just point out that these websites are not specification tools, because you still need to know what you need to buy. If you're sizing a battery, you need to know exactly what attributes you need for your design. They're filters. Same thing with a circuit breaker. These websites help you filter to find a product that you specify. So they're not specification tools. What's problem number 4? There's lack of harmonization in the industry. Let's say you do end up finding the product that you feel like it will meet the requirements during the ideation phase. And let's say you do find another one that could serve your purposes. How do you decide between 2, 3, 4, or even more of them? You look at data sheets. And this is what a typical data sheet looks like. A typical data sheet has your electrical, mechanical, environmental specification, some description about the product. And here's another data sheet from another company, and here's another data sheet. These 3 data sheets represent a converter. But what you notice is that while they carry the same information, they're represented very differently. It's very difficult to compare the information in those data sheets. They have different styles, different attributes. Names are in different locations. There's different formatting. Some show graphs, some don't show graphs. They have different units. I mean, the list goes on and on. And on top of that, they have missing information. In order for you to make a decision if a component is good for your microgrid, you need more information that's represented in those data sheets, like internal DC capacitance. Does the unit have internal protection? Are there paralleling methods? What are the control methods? And so on. Problem number 5. The information that you need that's not in a data sheet is fragmented. We know that not all data sheets have the same attributes, and not all data sheets have the same relevant attributes. So during your ideation phase, when you're trying to figure out, is this going to be a realistic scenario? What do? You email. You go and find somebody's email on a website, or you find them on LinkedIn of a sales guy or an application engineer. You say, hey, Mr. Application Engineer, does this component have these particular features? And if you're lucky enough, you get a reply. And if you can't find stuff in an email, or I should say, they can find stuff to email you, they typically forward you either data sheets or spreadsheets, or more installation manuals or operation manuals. And if information is not available anywhere documented, typically companies resort to tribal knowledge. And so this is a big problem in the industry when you're trying to compare several pieces of equipment. It's an extremely time-consuming process. Problem number 6. It's a lack of collaboration. This is probably the only industry that I've worked in where it feels like everybody's working in silos. Information is proprietary typically, and it's available to a few privileged. Solutions are proprietary, meaning solution from company A does not play nicely with solution to company B. Everybody is competing for their own proprietary information and their own proprietary solutions to provide the solution for the renewable energy microgrid. Consultants are extremely expensive. Information is out there, but it adds to the bottom line of any microgrid project design, and it can stop it before it even starts. And then the product manufacturers are working in silos, trying to figure out what is the best product to make for the market. So in summary, the problem to accelerating the adoption renewable energy microgrids, AC or DC, is that the entire process is complex. And we won't solve everything today. Today we're going to start with fixing the 6 problems during the ideation phase. So there is a lack of ideation tools. Products don't have a place to live and call home. There's lack of harmonization amongst data sheets and equipment. Information that's relevant to your design is fragmented and it's all over the place. And there's lack of collaboration. There are just too many proprietary, expensive tools out there that can help you ideate and iterate, share and collaborate your microgrid ideas and designs. So today, we're happy to introduce to you DCIDE, because you don't need a PhD to design a DC microgrid, but you do need a PhD to design DCIDE. It has always been our goal from day one to design a software tool that's open, that's collaborative, that's intuitive first and foremost, but very capable. And this is a very difficult thing to do because you have to move the complexity behind the curtains, as we say. So this is our take on DCIDE. And today we're going to launch it in beta format. The tool does not have all the features today. The tool does one thing and one thing really well today. It helps you get your thoughts out very swiftly. It helps you design microgrids at the speed of thought. And we'll demonstrate it to you later. So DCIDE today has drag and drop functionality. You can drag a piece of component that belongs to a microgrid and drop it on a schematic, because the design of a microgrid should not be more complex than that. It allows you to share your creations. It allows you to duplicate your drawings in case you want to iterate. It allows you to export in different formats if you want to add it to your presentations. Icons are standardized. Items are being auto-tagged. Lines are being auto-color-coded, auto-labeled. And it's really aiding you to make sure that you can focus on your design and not be distracted by connecting lines and coloring and labeling and annotating. We feel like this is the perfect place to start. But even better, DCIDE is accompanied today with a product catalog. Remember the problem with the lack of harmonized data sheets and lack of finding availability of products on the market? Well, we decided that we need to create our own product catalog. Our own product catalog that focuses on DC microgrid specific equipment. We wanted to make sure that the search is extremely intuitive. We wanted to make sure that you find products based on manufacturers. And we wanted to make sure that we rethink which attributes are absolutely necessary to compare products for various categories. So today we support 4 major categories. We support power conversion systems. We support batteries, circuit breakers, and EV chargers. There's a lot more to come, but we feel like this is a good starting place. So let's take a look at what a harmonized data sheet looks like. This is a power converter from a company called CE+T. Your data sheet shows the basic information about the product. But what you can notice is there are attributes and fields that are relevant for being able to compare a converter from company A to company B. So if you do pull another converter in, like we've shown here from Amped, You can side by side compare the features and functions, and we'll show you more in a demo. So we have the product description, electrical specs, mechanical, environmental, port configurations, communications, and even performance specifications for the product. Here's another category. This category represents circuit breakers from company A, and we have a circuit breaker for company B. These harmonized data sheets allow you to compare the relevant attributes for the products that you're trying to compare to be used in a microgrid. And so we're really proud of this, and we will continue adding more products and creating new categories as we move forward. On top of that, we're going to be launching free design templates today. These are microgrid design templates for various microgrid styles. So you don't have to start with a blank page. And we're going to keep adding templates. Whether you want a community microgrid, a residential microgrid, a commercial microgrid, an industrial microgrid, you have a place to start. You can edit, you can share, you can invite others to collaborate. And best of all, you don't have to start from a blank page. So, let me show you a quick demo of how easy it is to build a DC microgrid inside DCIDE. All right, so let's build a DC microgrid. Every DC microgrid has a single point of connection to the utility because the sun doesn't always shine, and you may not want to pay for all the on-site renewable generation and storage assets. So we drop a utility connection in. Let us drop a converter, and let us drop a battery onto the schematic. Now, these are generic components, but look what happens when we start connecting components together. The system knows that a battery is a DC component, and it automatically configures the port of the converter to be DC and color codes it blue, and it even shows you the power flow directionality possible with that component. Now, this presently is a 2-port converter. Port 1 is AC, and it's bidirectional, and port 2 is DC. This is a generic library, and you can go ahead and attach specifications to it. So you can say 480 volts, 44 amps, nominal power 30 kilowatts, and you can specify the directionality of the converter. So 30 kilowatts, and it's isolated. You can do the same thing for DC 2-port. You can say, yeah, the minimum is 100 volts, maximum is 1000, nominal 500. Let's say the current is 60 amps and 30 kilowatts, bidirectional, isolated. And you only have to do this once, and the information is with the equipment. So let's build a microgrid. What else is part of a DC microgrid? Typically, you have a DC distribution panel. So let's add a panel and let's resize it. Notice how easy it is to resize this panel. And notice how there's auto tags and auto labels for each piece of equipment, keeping track of which equipment did you drop onto the schematic. Now, let's go ahead and connect this DC panel to the converter. Notice how the symbols have changed automatically on the converter side. Notice how now there's a 3rd port, and notice how the isolation is very clearly shown on a schematic. So these are dynamic symbols and dynamic schematics. Let's say this is a DC panel, and bam, just like that, the colors have changed to blue. Let's go ahead and add solar because this is a DC microgrid. So we're going to go ahead and attach solar. solar is unidirectional, and solar is DC. So you can see how easy it is to build a DC microgrid. But a DC microgrid has loads as well. So let's add a DC load, for example. And we're going to add an HVAC. So what we're going to do are to add an HVAC system, and let's make it more real. So today we're adding a train HVAC system. Train actually manufactures a dual input residential heat pump HVAC system that runs on 277 volts AC or 350 volts DC input power. And this is one of the very first and true DC air conditioning systems, because you can either use it with an AC grid or you can plug it directly into a solar storage system with a converter. It's really that easy. We actually ran this component at RA Plus without any issues. So this is very exciting for the entire DC industry, because you can have these on-grid or off-grid air conditioning systems. Okay, but let's go ahead and add an EV charger, since EV chargers are now DC. So we just click twice, and bam, just like that, we've added a DC EV charger. Now, I guess we just noticed that we forgot to add a couple components. I forgot to add overcurrent protection between the converter and the panel. So I'm just going to drop a circuit breaker in between. Notice how the system automatically cut the line, reconnected it, and labeled it as DC. So you don't have to move lines around. And let's add a DC-DC converter to the DC panel. This can be your charge controller. This can be a charge controller from AMP, and this can be a circuit breaker, let's say from ABB. And let's make this a Savant battery, and then let's make the EV charger an Ampere next. And this 3-port converter C plus T, let's say 30C3 model number. And just like that, you have a DC microgrid. It's intuitive, it's drag and drop, it's quick. You can save it. You can say DCIDE demo online. This is a demo for launch. The customer is DP, and you can save the project. Once you save your project, you can go ahead and share. So you can say customer at directenergypartners.com, and you can invite a user. You can invite the user as view or edit. You can simply copy a link, and you can invite a team member from your own company to collaborate. Or you can decide if everybody who has access to the URL can view. So we're making collaboration extremely simple and extremely intuitive. It is up to you if you want to keep it within the company or if you want to share it with the rest of the world. You can also export the schematic as an image in case you want to add it to a PowerPoint presentation. Or you can duplicate it in case you want to make another variant of this, but don't really feel like starting from scratch. But let's go ahead and look at the product catalog. This is the product catalog. The product catalog has an intuitive search component to it. So you can search, for example, a converter. You can quickly jump into categories. We have 4 main categories today: a converter, an EV charger, a circuit breaker, a battery. And we support at launch the following manufacturers: ABB, Amped, Elencan, Ampernex, C+D, Carling Technologies, DC Systems, and Meanwhile. This is what's available at launch. But let's go look at a live data sheet. So if you choose to pick a converter, on the right-hand side, you can filter. You can filter by manufacturer. You can filter by minimum voltages. You can filter by port configurations. It's really that easy. And so you see, when you're browsing a product in our catalog, we'll show you the most important information that you need when you need it. So you can very easily compare. You can see this is a 2-port converter, but there's also a 3-port variant. It's easy. So let's open up the data sheet. The data sheet shows you a quick description. And you quickly get into the overall electrical specs. And you see the port configurations. It says it supports AC, port 1. But it also tells you that the power flow is bidirectional. It's an isolated converter. And you can parallel 8 of them together. And the built-in features are voltage measurement, current, and power measurement. Now this is very important for controllability. Then you can go look at port 2. Same relevant information. It has built-in surge protection. And you can also see the performance as well. You can see this is a 95.5% efficient converter. Oh, and look, there's communication interfaces. This converter supports Modbus TCP, Modbus RTU, Ethernet, RS-485. And there's mechanical, environmental, and there are pictures that are coming. And we have attached application notes, installation manuals, and data sheets. And let's take a look at one. So it's really easy to reference the documents during your design. But let's go ahead and look at another converter. Let's say we want to look at a converter from Elencan. This is a DC-DC optimizer. Notice how the data sheet looks exactly the same, but this time you have 2 port configurations. This is an isolated converter, supports Modbus TCP, Modbus RTU communication, and again we have all the relevant information attached. So now when you're browsing converters, either from Amped or from Meanwhile, or from C+D, or from Elencan, or from any other manufacturer, you can very easily compare them side by side. Let's look at another category. Let's look at the circuit breaker category. Here you see we have all the DC circuit breakers. And this is a circuit breaker from ABB. But now notice how the attributes for circuit breakers are very different. We're concerned about polarity. We're concerned about the voltage per pole, how much it's being supported, how much current it can support, what is the inductance, the inrush current, what are the built-in features of the converter, the instantaneous short circuit current. And there's mechanical and environmental features. And of course, we attach data sheets. Now, whether you're looking at a circuit breaker from ABB or Carling Technologies, the attributes are the same. So it makes it really easy for you to compare. Well, let's look at DC Systems with their solid-state circuit breaker. Same attributes. It's really easy. So, you've seen how easy it is to draw microgrids at the speed of thought. You've seen how easy it is to find and compare relevant products in our new product catalog. So we'd like you to start designing today. And if you go to v1.dcide.app/draw, you'll be able to ideate immediately. The cost is free. The version is beta. This is very important. We decided that we're going to launch with these sets of features. We know the tool is not perfect, and we understand that not all the features that you may want are present today. But we feel like we're at the right starting point where we can add value to your design process, and we can also get feedback from you to make sure that we're developing the right features. We support US and Europe. We're committing to releasing new features every 2 weeks. And we're going to have a public roadmap. The importance of a public roadmap is that you'll get to follow us on a journey as we make DCIDE the world's #1 microgrid design tool. The tool that will accelerate the adoption of renewable energy DC microgrids and eliminate the soft costs across the entire design lifecycle. We believe it's important to be open, we believe it's important to collaborate, and we believe it's important to get feedback. So with that, I'd like to say thank you. There are 3 links on this last presentation site. One will take you to LinkedIn, where you can follow our progress, and we will be releasing new features every 2 weeks. The middle link will take you to DCIDE, so you can draw immediately. And then the third link will take you to the templates. There's one more thing. Inside the tool, on the bottom right corner, there's a feedback. You can report bugs. You can report new feature ideas. So with that said, I'd like to say thank you. And I really look forward to changing an industry with you. Thank you.